So, my name is Carl Jonas Adebring, come from Tieto, and I'm here to talk a little bit about what we're doing within the 5G area, especially around the UPF, and also a little bit around UCP and Edge. So, to start a little bit, how about Tieto? Well, we're a company that is over 50 years old and based out of the Nordics, very focused on technology, and last year, Thomson Reuters rated us as one of the 3 technology companies on their global list from the Nordic region, and of course the other 2 were Nokia and Ericsson. So we have about 15,000 people, and I come from a smaller area, this called Product Development Services. So we are usually working with global companies, working on very advanced technology, actually building a lot of 5G connected cars, smart devices, cloud platforms, and of course, a big strength within the telco area. So within the connected area, and especially the telco world, we are of course working a lot on infrastructure, a lot on these software-defined pieces of the puzzle, but of course a lot around infrastructure, edge, and of course, automation, ONAP, orchestration, and so on. So, what are we going to talk about today? Well, I'm sorry, we're not going to talk about the super cloudy, data center network, spine leaf router, service mesh, or 300 plus gigabits per second systems. Sorry, not today. We're going to talk about very edged focused SDN. So what is then edged focused? Well, it is close to the access, it's close to the application of the actual software. And of course, it's very close to the 5G and RAN edge. And as you probably all know by now, distributed applications are not that simple. Trying to get the same container running in your data center and then trying to move it out towards your, small data center, MEC or CRAN, you suddenly run into quite a lot of more interesting problems than you ever had before. So what we are going to be talking a little bit about today is actually going into 2 deep dives. The first deep dive is around the user plane function, UFP, for 5G, and a bit about RAN packet processing. And the other one will be going a little bit deeper on what we're doing in the UCP area and a few lessons learned. Okay. So at Barcelona at the Mobile World Congress this year, we showed basically this picture. So we actually showed a 5G UFP running on containers. As we are part of developing a lot of 5G baseband and software and RAN pieces, to do that we were forced to create simulators so that we can actually develop the different pieces, which means that we can simulate the UEs for a whole city running 5G type workloads. And by connecting these to these user plane functions and having these loads going through, you can actually learn quite a lot about how the different systems are and where the pieces kind of fit together. And what we want to talk a little bit about here is just show a little bit of the architecture, but also share a few lessons learned from this. So, very shortly, and we will just, maybe tease the software stack. Basically, we have these 5G applications, and these we've been starting working on even from the VM side. So they used to be running on VMs. And of course, we're using the same open source tools like everyone for actually doing the monitoring. We're using Grafana, we're using InfluxDB, we're using Logstash, and so on. But the new thing here is, well, what if you don't have your VMs where you've done all that complex data plane stuff, but you're actually trying to move it to a Kubernetes type infrastructure? So the way that we did it was that we worked with the Multus CNI. We worked, of course, with SRIOV, we used Flannel, and of course, we used a lot of technology to accelerate containers, including the Intel, the Container Experience Kit. Very shortly, and I'm not a super networking guy, but this is basically how we created the Kubernetes networking from the pod down to the different hardwares. And this can, of course, be connected to both SmartNICs and other pieces, and I will get to that one further. So what we had then in this demo is that we had two different applications. One application for actually creating the traffic, sending the traffic from these realistic simulators of 5G traffic, down through the PCI driver to SRIOV and down to the 40 gigabit NIC. And then having the user plane function that should be able to handle this traffic, having the same cable connections, but you're actually having dual connections up. So you're having a VF0 and a VF1 going up through VPP and then connecting to a regular interface to the application, DPDK interface. And of course, to do that well with performance, you actually need to work with these user space drivers and have the connections. So what are the lessons learned from this demo? For some of you, this might be very known things, but I think it's quite interesting that on a quite simple server, we could actually run about 7,000 UEs and 20 gigabits of traffic, unoptimized from a single Kubernetes cluster. So by adding SmartNICs, by accelerating more, or just by adding more hardware, you can actually reach quite high degrees of traffic without making it overly complex. And of course, when it comes to the networking, there are some issues to handle. Scaling is, of course, one of the key things when you're both talking about 5G and if you're trying to get more efficiency out of the systems. And this was something that you really need to spend a lot of time on, getting the right pinning and getting the dynamic pieces connected to the Kubernetes. We were actually forced to do a fork of the SRIV CNI plugin, and I think this might have actually been upstreamed by now, but you actually have to go in and fix some pieces to make it work from time to time. And then, of course, service discovery was not working as we wanted it back then, so we actually had to use console as a workaround to get it working. Okay, so what are the lessons learned then from working with 5G and these user plane functions? Well, one of the first things that we kind of noticed is that you really need to have a deep understanding of the 5G and RAN architecture. And there are things from every generation that can be brought into this one. So you need to have the control plane and the CUPS expertise to be able to connect it in the right way. And you need to know what software pieces are actually used in the 5G core. The second part is, of course, that you need to know how to do cloud-native scaling. And who in here does cloud-native scaling today? Okay, nobody raises their hand. Okay, well, that makes sense. What we kind of tell is that to be able to do this well, you actually need to know both how to scale within cloud-native, scale within your Kubernetes cluster, scale within your available CPU nodes or compute nodes, but you also need to have the knowledge of both the RAN and the cloud-native domain to do it well. And then, of course, container networking. It is getting simpler all the time. I think a lot of work has been done in all the open source projects to enable this one. But to really push ahead, you need to know how these interfaces work. You need to know how to optimize the performance. And you can use shortcuts like using the Intel Experience Kit to get things up and moving much faster. And of course, if you don't want to do that, you can come to us and we can help you. Okay, so very shortly then, a little bit on the second deep dive, the edge computing, or the UCPs. And I think we all know the kind of basic promise of edge computing, so I won't repeat that one too much. But what everyone wants is that, they want faster introduction of new services. You want to get out in the market faster. You want to use the hardware that you're already paying a lot of money for in a more efficient way so that you can get new services, more services, or aggregated services. And of course, improving operations, improving the quality of service, having it so that you get zero-touch automation, service assurance built into the platform or built into the applications is the way that you will actually save money over time. And we are, of course, working with large semiconductors like Intel on enabling this, and of course with a lot of our customers in this area. So, what is UCP then? Well, to us, it's quite much a technology ecosystem. There are tons of these common technologies: Kubernetes, Cloud Native Computing Foundation, NetConf, OVS, OpenStack, Calico, and I'm not going to just read them from the screen. The interesting part is that there are some specialized initiatives for telco. And of course, ONAP and Aquino and Airship and even Danos are some of the ways that we as an industry is trying to find common ground and cooperate around enabling these basic platforms. And there are even these initiatives for AI or IoT or even automotive, using similar technology but applying it in slightly different ways. Some of our engagements, and these are just a few of them, is that we're quite active working with the different semiconductor vendors, trying to enable the hardware and the components to make it easier for you guys building software to do things on top of the hardware. You get more things out of the box, more things out of open source, and so on. We're also working quite a lot on actually transforming the applications, moving the applications towards cloud native, solving these tricky pieces that say, no, we have to do it in the VM because of A. Well, what if we can fix A for you? What if we can solve this data plane issue, this scaling issue, this security issue? And then, of course, connected to that is a lot around acceleration. If it was easy to do and you could do it in the data center, then do it in the data center. But once you get out to the edge, you want to be very efficient on what resources you use and how the application can actually be accelerated to deliver the most performance possible. And around that, we're of course doing quite a lot of SI and support work, connecting the different pieces, enabling software onto hardware, connecting software to orchestration, or adding other components around that one. So, one thing that we wanted to share with you a little bit more today is a piece that we've been doing in the VPP project, FDIO. And this thing is called Sweetcomb. So within the FDIO project, together with Intel, we actually helped create this minimized and efficient SDN abstraction that can actually connect these larger pieces, these open daylight, Kubernetes, ONOS, or whatever, through a regular NetConf interface to the data planes of multiple nodes. For example, VPP, DPDK, and so on. And actually enable these kind of simplified control from the control plane to the data plane. This one we've been running in a few different options, and there is quite a lot more to come in this one. Wait, I'm going to go back one more. There's quite a lot of happening on this area because you can both use it to enable a very simple SDN control in an UCP box, but you could potentially even use this Sweetcomb application that is written in C++, so it's not a big Java application, to actually make your application cloud native and having the connections and the tunnels being set up by Open Daylight or any SDN controller without having to do that abstraction of actually building the VPP data plane and connecting it in a very complex way. So some of the next steps around this is, of course, a thing that we're doing together with Intel, which is called openness. And here the main usage is to say, well, if we have these hardware, if we have those edge devices, and we want to connect them all the way from the hardware through the hypervisors and the kind of base enablement, up through openness that helps you set up the basic nodes, help you download the images you need, and even adding an application layer like OpenBino that contains a lot of AI and ML and kind of visual control layers, so that you can connect these ones over the internet, through the data center, and doing these promise of having OpenMech. Because what we all want is that we want this cloud-native platform. We want these APIs and the high efficiency of making it happen. And of course, we want to have lifecycle management, so we're not having to go out and fix it all the time. So, what are some of the lessons learned from our work within UCP? Well, one of the key things is that you actually have to have quite a wide competence to make things happen. There are so many different pieces and there are so many different options that being able to choose between netconf or ODL and knowing the Tosca and Yang can become quite tricky. Working with the different data planes that are available on multiple generations of a hardware or multiple different chip levels or even multiple architecture is also quite hard. And being able to understand how the applications are evolving towards cloud native really makes it one step further, especially when you're adding the CI, CD, and test automation aspects of it. And for us, networking is one of the key things that people run into trouble with. So we can do some things to abstract and simplify networking. We have gotten a good piece of the way. And these kind of cloud connectors, abstractors, or agents, we believe will make a big difference within the larger community of enabling UCP and making the software that we all want to get. Okay, so a little bit of Tieto and a little bit of sales pieces, what we're doing. So the key thing that we are capable of is software integration and software R&D. That's where we have our basis. We're very strong within LTE and 5G applications, as well as networking and kind of performance optimizations. So we have been doing quite a lot when it comes to both DPD, VPP, OVS, and all these things around networking. We've even been doing things on the more open routing area. And of course, SmartNICs, routers, and the other pieces. But we're also adding quite a lot of focus now on the journey towards cloud native. Having these microservices, transformations, or breakdowns, doing the GitOps and the CI/CD to actually be able to build the pipeline that will deliver the software. It's not the software itself that is the main value, it's the machine that creates the software that will enable you to update and automate over time. And then, of course, connecting these to the big orchestrator that everyone is working on and everyone wants to make work. So, thank you. I hope you learned something, and if you have questions, please reach out to me, but you can ask questions already. We have 2 minutes 44.
Anyone have a question? I got a question. Microphone.
James Crawshaw from Heavy Reading. Just wondered to what degree you're seeing real-world deployments of universal CPE, and in which case, can you say sort of geographically where you're seeing most success?
I would say that it is happening right now all across the world. And of course, the SD-WAN use cases, and especially the kind of second generation SD-WAN that everyone is talking about, where you're not just buying the software and the box and the management, but that you're trying to do more white box and then add the software layers on top of that one, or even using more multi-cloud type management layers. It is happening right now. There are a few operators and markets that are pushing this one even further. And I think in a way, the enterprise market is pushing some of these technologies much faster than some of the more traditional vendors. But this is changing quite rapidly, and it's going to be an interesting part to see. For us, we're quite strong in the Nordic region, and we also have a global presence with both in China and, of course, in the US. So we're covering quite a lot, but I wouldn't go into the specifics.
Sure. Okay, thank you.
Anyone else?
Anyone else? We have time for one more question, if someone would like it. Okay, then let's...
Okay. Thank you, guys.